In simulation, once you have the variable, you have to know when you're picking the value of that variable, which figure are you going to go for? So we will be provided with what we call the random numbers, but you not just pick anyhowly. You have to provide a range into which your random number would actually lie. And as you pick now the value of the variable, it will be guided by that random number. With me, I have a small illustration on my variable here is X. This X could be something like the number of units. This X could be, for example, the time. This X could be maybe the duration of an activity if you're talking about the queuing in networking. This X could also be, let's say, the number of units demanded or supplied if you're talking of queuing, let's say, in inventory analysis, because those are our main areas where we are going to look at simulation. Number one, the CVP analysis, issues to do with revenue, profit, the cost, and the number of units. Number two, the case of what we call queuing theory. So variables will come in form of time. Then we also have the inventory, where we will be dealing with the quantities demanded or maybe supplied, and something to do with the number of units, let's say in our stores, when we are talking about the supply of goods from the store to where the production is taking place. Maybe we are also purchasing. So you hear of the language of in stock, out of stock. And again, we talk about, let's say, the cost of holding the stocks in the store. And then lastly, we have the inventory in networking. So your variable would depend upon what is that area of application. Like if today we are talking of the CVP analysis, then our variable here, which I'm calling my X, could actually be in, let's say, in relation to the number of units. Could be we are talking of the revenue itself. Could be we are talking of the cost. So once you have noted that variable, you'd want to pick its value. This value will be determined by what? The random number. And that random number will be provided, but the question is, it lies within which range? Usually, random numbers will come in form of either one digit. They'll also come in form of 2 digits, depending on what is actually provided. They'll also come in form of, let's say, 3 digits. Those are the commonly used random numbers. So when you're assigning this, how do you begin assigning the random numbers? In the first category, let's say we have the 1 digit random numbers, let's say given, you'll be assigning the random numbers in form of 1 digit. And we follow the language of probability in that the sum of the total probabilities in a given random experiment or in a sample space cannot go beyond 1. So when you're assigning the probabilities, they should actually start from 1 all the way to 9. If you are having, let's say, your random numbers coming in form of 2 digits, then your random number should be assigned from 0, 0, because they have to take 2 digits, all the way to 9, 9, okay? Because we talk about the language of probability given either in a decimal or, let's say, in percentages. Then in case we have the random numbers coming in form of, let's say, 3 digits, you're going to assign them all the way from 0, 0, 0 to 9, 9, 9. And if they go up to 4, which is a rare case, actually, you take the number of digits to be 4. And you don't accommodate 10 here, neither do you accommodate 100 here, neither do you accommodate 1,000 here. So your random number should actually be between 0 and 9 if they are in 1 digit variables or figures. If they're in 2 digits, they'll be starting from 0, 0 all the way to 9, 9. And if they are in 3 digits variables, you'll be assigning them from 0, 0 to 9, 9, 9, 9, okay? but it will depend on which range are you talking of. These particular probabilities are the ones to guide us. So in my illustration, let me assume the value of the random variable x equals to 10 will take a probability of, let's say, 0.1. Then the other one will take a probability of, let's say, 0.4. Another one, let's say, 0.3. And remember, probability values cannot go beyond a 1 in total. 0. Let's say the balance there is 2. And you can consider here to get the total, this should actually sum up to a value of 1 in total. Okay? How do we cumulate? We are going to cumulate in form of what we call a less than cumulative form, starting from the first value here as we move towards the last element, yeah? As we go down from top to bottom, we keep on adding as we go to the next value. For the first one, there's nothing to add, so it will still remain as 0.1. The next one, we are topping up, we are topping up 0.4, so we'll have 0.5. The next one, we top up 0.3, so we'll end up having 0.8. And the last one, as we top up 0.2, we'll have a total probability of 1.0. And because here I'm having my probabilities to 1 decimal place vary, I go back to how the random numbers were given and I see whether they are uniform. If these ones are in 1 digit, then my probabilities here should be in 1 decimal place value. I repeat, if the random numbers here given are in 1 digit, then my cumulative probability should be in 1 decimal place value. If, for example, they were given, let's say these random numbers were given in form of, let's say, in form of 2 digits, then I would have constructed my probabilities here in form of 2 decimal place variables, so that when I'm assigning the ranges here, I'll be taking them into 2 digits. I repeat, the way I have done it here, yeah, that is in form of 1 decimal place variable. That 1 decimal place variable corresponds to my 1 digit here as my random numbers, okay? If there were the random numbers into 2 digits, I would have constructed my cumulative probabilities, or even to have changed my probabilities to be assigned to decimal place variables, so that when I am assigning the ranges of my random numbers, they will correspond to the numbers given as my random numbers. So how do I come here to assign the ranges now? Since I'm talking of 1 digit, and what we normally do when we are assigning the random numbers class is that we don't include the upper element in our cumulatives. So we normally use what we call the exclusive form of assigning. The exclusive form of assigning the random numbers. They are assigned in form of exclusive form, in that we don't include the upper value, the upper element occurring in our cumulatives. So my first range would take a 0. If I were to go up to the next one, then I would say 0 again. So we just assign 1 0. If let's say here I had a 2, let's assume here I had a 0.2, I would have stated my random number range to be 0 to 1. I avoid 2, okay? If it is like what it was earlier on, since the upper element in my cumulative is 1, I cannot go up to 1 because I need to exclude that. Then the next one should start from 1 now all the way to 4. I am excluding the 5 here. Then the next one should start from 5 all the way to 7. And lastly, we'll have between 8 and 9. As we had said, our random number should actually be ranging between, look at this, between 0 and 9. I want to use the same illustration, but I'm going to adjust my probabilities here, and I'm also going to adjust my random numbers so that we see what if they're taking the 2 digits. How are we going to do that? So maybe we can carry this. So in my next illustration, let me do away with this. So let's assume that our probabilities given are the same as 0.1, 0.4 there, 0.3. But now coming to, let's say, the random numbers provided, which you are going to assign to your random variable. Our random numbers here given are as follows. We have 0, 0, we have 0, 3, we have 0, 4, maybe we have 0, 7, and maybe 0, 9. Just giving an example. Let me call this one 17. Let me change this one to 44. Maybe here we have something like 89. Yeah, that's okay. And we want to assign the random numbers to these particular variables so that we will be able to pick, let's say, a given value that will guide us in our workings. So because my random numbers are now coming in form of what we call two digits variables, I must construct probabilities in form of two decimal place variables. So here my probabilities given, this is what is given in a problem, but in my calculations, I have to take them into two decimal place variables. I'm not changing what we are given. These are the same probabilities, but as you do your workings, you must have changed those probabilities to appear in what we are calling two decimal place variables, okay? So these ones have taken two decimal place variables. Then we cumulate. So I'll start from 0, 0 to 0, 9. I avoid the last element indicated in that particular category. Okay? Then I must include it in the next category. Whatever I avoid in the first category, it must appear in the next category. So I have 10 to 3, 9. We move to 4, 0 to, we have not cumulated. Sorry for this. We have not cumulated yet. We need to cumulate before we assign random numbers. Sorry for that. So we start by cumulating first, 0.1, 0. We add it to 0.4, so we'll have 0.50, 0.50. Then we'll have 0.8. We can add a 0. Doesn't make any difference. And lastly, we'll have a 1. Okay, and you can see we are still maintaining two decimal place value. Now we can assign the random numbers. We'll start from 0, 0 to, we have avoided the last element in our category. We include it in the next category, okay? But here we'll go up to 0, 9. Then the next one, we'll have 1, 0 all the way to 4, 9. Then the next one will start from 5, 0 all the way to, we get to -1 here, we'll have 7, 9. And lastly, we'll have 8, 0 all the way to 99. So you see now the range to which our random variables are taking, that interval is between 0, 0 here, between 0, 0, all the way to 99. If they were in 3, let's say, digits, what you could do here is to add another 0, yeah, so that when you're assigning, you'll be able to take care of that. So important, before you do anything, let's have the ranges, for example, constructed, so that when you're assigning the probabilities, yeah, you'll have noted how do you do that, because this will have to be guided by whatever the random numbers are given. And if the random numbers are coming in form of 3 digits, then your probabilities have to appear in 3 decimal place variables. If they are given in form of 2 digits, then your probabilities have to appear in form of 2 decimal place variables. So very important to look into that. With that now, let's look at an example where we can be able to work on with the given random numbers. We are going to work on an example, and this will actually be on the CVP analysis.